Good morning to everyone. Now, in this session, we'll discuss the second topic in the Unit 1, that is design philosophies. Going to the next slide, design philosophies. These are all the three design methods which are used in the design of RC structures. So the methods are working stress method, ultimate load method or load factor method, and the limit state method. See, according to this working stress method, this method was developed in the year 1900 up to 1960. This method was used. So, due to this, due to some drawbacks and some limitations in this method, there is one more method developed, keeping into consideration of drawbacks in the working stress method. That is ultimate load method. So, after 1960, this method was developed. Again, due to some more limitations of using this method, so the one more method developed is a limit state method. So this limit state method, right now what we are using is this limit state method. Now let us see one by one the design philosophies of all the three methods. We'll go to the next slide. That is the working stress method. In the working stress method, it is based on elastic theory. As according to this method, like certain assumptions are made in this method. So accordingly those assumptions only the structures have been designed. So the first thing is like steel and concrete acts together elastically. This is what the first and foremost assumption is made in this method. And again, further, the one more assumption is like the plane section remains plane even before and even after the deformation takes place. So this is one more assumption is made. And also the second assumption is like stress strain relation under working load is linear for both steel and concrete is considered. This is one more assumption. And then next, the tensile stresses are taken care by reinforcement and none of them by concrete. So according to this method, this one more assumption is made. And finally, the last assumption is the modular ratio between steel and concrete remains constant. So having these all assumptions, this method was developed and accordingly it is followed. So by in adopting these, so certain limitations have been observed during the period. So those limitations are like as it is assumed in that the stress strain relation for concrete and steel both are linear, but which is not actually true. It is. So since the stress strain relation for concrete is not a linear, it is a non-linear curve. So this is one more drawback in the working stress method. And also in the working stress method, the more factor of safety is considered, that is up to 3 is considered in the working stress method. So by doing so, so it gives an impression that the failure load is equal to the factor of safety times the working load, but actually it is not true, which is not true in reality. So this is also one more drawback in the working stress method. And also by adopting this method gives very uneconomical section. So having these all limitations, this method was eliminated in the year 1960. After that, the consideration of these limitations, so one more method was developed that is called ultimate load method or load factor method. See, again, according to this method, as we have seen the drawbacks in the working stress method, so the working loads are increased by load factors to obtain the ultimate loads. So this is an assumption made in this load factor method. Again, in the ultimate load method, the stress condition, that is the stress distribution at the state of collapse of the structure is analyzed. Means for the loads only he has considered for the analysis. And also it takes into account the non-linear stress strain behavior of concrete. As we have seen the drawback of the working stress method, that is linear, not linear. No? So that is also incorporated in the ultimate load method. So even though this method is used for further to some more years, and the most safety measure in this design method is used by the use of proper load factor. So having these all assumptions, this method was is used for the design of a structure. And one more thing, the drawback of this method is again like it does not give any give guarantee about the serviceability performance. So that is the reason. So again, this method is also dropped after certain years. So then keeping into consideration of some more failure, as you see, the satisfactory strength performance at ultimate loads does not guarantee the satisfactory serviceability performance at normal service loads. So having this drawback in this method, to develop all these limitations, so the one more method was developed that is called the limit state method. So according to this method, the main object of this method is based on limit state concept. So limit state means it is to achieve acceptable probability that a structure will not become unserviceable in its lifetime, which means it will not reach its limit state. So this is what the main object of limit state method. So according to this method, the limit state is an acceptable limit for both safety and serviceability before which the failure occurs. See, the one most thing in this method considered is here considerations of both the strength and serviceability parameter. See, here in this method, the strengths are underestimated and the loads are overestimated. So having the concept, adopting this concept, this method was useful, were very much used in the design of concrete structures. Again, in the limit state method, we'll see the two limit states, that is the limit state of collapse and limit state of serviceability. So this is deals with the strength performance, and this deals with the serviceability performance. So likewise, we'll see in detail about the collapse and serviceability. In the limit state of collapse, the structure may get collapsed because of the one of these reasons, that is the rupture at one or more cross sections, or buckling or overturning. So keeping into consideration of these all failures, the some more stresses, the limit state of in the limit state of collapse, the stresses have been considered. That is, those stresses are flexure, shear, torsion, tension, and compression. So these all comes under in the limit state of collapse. Next, after designing the structure due to collapse, it is checked against the serviceability. That is limit state of serviceability. So the second limit state of serviceability, in that it includes deflection, cracking, and other limit states such as vibration, fire resistance, chemical and environmental actions, and accidental loads. So keeping consideration of these all limit states, the structures are checked against the serviceability. Now we'll see next the stress block parameters in the limit according to the limit state method. See, certain one assumption is made, the concrete cross section of a concrete beam is considered, so which is of width b and effective depth d. So for this structure, after upon loading, the stress and strain diagrams are also drawn for the analysis, for the observations of a structure. So in this, as you are seeing in the figure, this is what the strain diagram of a particular element, that is concrete and the steel. So this is what the neutral axis above is showing the strain in a concrete, and below the neutral axis strain in the steel. So likewise, we will see further in detail next. And also the stress diagram. The stress diagram for the beam is also shown, and due to the stress diagram, the compressive force is balanced with the tensile force. Anyhow, the knowledge of this stress block parameters is required for the upcoming topics in the unit 1. So this is up to this. This is about the second topic in the unit 1. Thank you.